everybody! You might be wondering if the title of this video is one we've seen before, and the answer is yes. So we're going to be kind of creating the same function that we saw in our MATLAB unit, the alternating list, but we're going to talk about how we can create it in Python. So our big goal, as we have written here, is to write a function that creates a length n list of alternating 3s and 7s. So it's going to go 3, 7, 3, 7, 3, 7, and so on, until it has length exactly n. Now, if you think about all of the things that are going to go into creating this function, there's going to be a lot of things that we haven't seen in Python yet. So for instance, how do we even define a function? Things like if statements, all of that. So to solve this task, we're going to break it into a bunch of smaller pieces. And one thing I want to emphasize is we've already seen examples of functions, if statements, for loops, logic, all of these programming fundamentals in MATLAB. So what's cool now is we're going to see how it's done in Python, but the underlying concepts and logic are going to be pretty much the same. So if you want a more in-depth look into, okay, how do for loops work, what's the logic behind a function, that kind of thing, I believe our MATLAB videos would be a good place to review just because we go into a little bit more depth. Whereas here, I'm going to show you the syntax, but we're not going to spend as much time talking about exactly how these things work and why they work the way they do. So with our big goal in mind, the first thing we want to do is to create a constant list. So this is kind of a good kind of halfway step where instead of having it alternating, can we write a function that takes as input a natural number n and as output returns a length n list that just has all 3s? So that's a pretty good place to start. So let me show you how to create a function in Python. So what we do is we start with the word def for definition. Then we put what we want to name our function. So maybe f, and then we have parentheses, and then we tell Python, well, what input do I want? And in this case, I expect an input n, or that's what I want to use. And then here, this is different than in MATLAB. We're going to need to use the colon. Now, when I press return, notice the indentation. It's very important that whatever I want to happen inside of the function has to be in this indented block. So if I were to leave the indented block, these things would be happening outside of the function. But now, let's start by kind of doing what we did in MATLAB, something very familiar. Let's create an empty list. So I'm going to say my list equals, and then I have an empty list. And a little bit further down the line, we're going to learn how to do this using something called list comprehension. So this is by no means the most elegant or sophisticated way of coding this function, but it is a very natural way and a way that translates well from other programming languages. So let's keep on this route. So okay, we have an empty list. Now we want to populate it with n 3s. So I'm going to say for I in range of 3, or n, sorry, because remember our input is n, and we want it to be length n. And you'll notice we're not going to use the variable I anywhere. So again, well, that's not what a dummy variable means. It is a dummy variable, but more than that, we're not going to actually use it. This is just telling us to kind of iterate through the for loop a number of times. So sometimes what you might see when you're reading code is people will use an underscore to represent that it's not going to come back, but let's keep it with I for now. If you do see me use an underscore in future videos though, that's why. And again, okay, so now we have for loop, so we need colon. Now notice we have 2 levels of indent here. So I have first level of indent tells me what's in the function. Second level, it tells me what's in the for loop. So now in the for loop, I want to say my list dot append, and I want to append 3. So now I'm going to run this code. And we didn't get any errors, so that's good. But let's try running the code and see what happens. So let's say I try to run f of 3. So nothing happened. And take a look at this code and see if you can figure out why. Is there anywhere that we tell the function that we need to return my list? So back in our MATLAB unit, part of defining the function was you said exactly what you want your output to be. But what we need to do in Python is we need to explicitly say return this, return my list. So I'm going to make another mistake, see if you can catch it. So let's say I'm going to use the keyword, oops, let's see, 1, 2, 3, 4, return, and oops, let's see here, I think the indenting was off. That's why the my list was highlighted red. So just so I can convince you that the indenting wasn't causing an issue, I'm still going to save this. I'm going to run F3 and we still get the same thing. So it wasn't an issue with my list. But now, okay, let's say return. Oops. Return my list. So again, I run. Nothing happens, no error. But let's see what happens now. So remember, f of 3, I expect this to return a length 3 list of all 3s. And I can see here what happens is I just get 1, 3. So take a look at this code and see if you can spot the mistake. So we start with an empty list. For I in range n, so we enter the for loop, we append 3, but then we return my list, so we leave the for loop and we're done. So what we really need to do is have this return statement outside of the for loop. So we go through the for loop n times, we append 3n times, and then only once we've done that, we return my list. And again, the way that you can tell this is happening outside of the for loop is it's not indented within the for loop. So it's still within the indent of the function, but the for loop indent it's not a part of. So let's save it and let's try it again. I'm going to run it now. Let's try with maybe not 3, let's try 5. And let's see, we're still not happy with this, so let's see what's going wrong. There it goes. I think I probably just didn't run the function again. So okay, here we have 1, 2, 3, 4, 5. That's looking good. Let's try it with an even number just for good measure. Let's say f of 4. And here we get 1, 2, 3, 4. So that's looking good. One thing I want to emphasize is you might be wondering, okay, so like let's say we try something like the following. So let's say I do f of 6. Now the way this works is we go into the function and we see, okay, 6 or n, and everywhere we see n, it's going to get replaced with 6 because that's what we're putting as our input. So here we do I in range of 6. So here I can run this and I can see 1, 2, 3, 4, 5, 6. So you might be wondering now, well, is n defined to be 6? So for instance, I can come here and I can say n, and you can notice I get an error. It says the name n is not defined. So it's true that n gets set to be 6 within our function, but that doesn't happen outside of the function. So n outside of the function is undefined still. I could say n equals 100. So here n equals 100. So then it gets defined. Then what I can do is I can say, okay, what about f of 4? So I get here 1, 2, 3, 4. But then if I say, well, what's n? It's still 100. So this should be very familiar and something that we saw a lot in our MATLAB unit. These input variables, these are locally defined, so this only affects the function. So outside of this function, n is anything that you want. It's not dependent on this function, so we don't need to worry about like it interacting with anything else. So another way of saying it is that this n is a local variable. I think this is a good place to stop this video. In the next video, we're going to see the first version of our alternating function. Thank you for watching, and I'll see you there.